Hello everyone, today we will see the problem 81 raised to the power sin²x plus 81 cos²x is equal to 30. We have to find the value of x. So let us start. 81 sin² x plus 81 raised to the power cos²x equal to 30. Now we have to find the value of x. So let's start. We have to use here formula sin² theta plus cos² theta equal to 1. We have to convert this same power of 81. So we will write this formula in the form of cos² theta equal to 1 minus sin² will shift this side, sin² theta. Now we will apply this here. So we can write 81 raised to the power sin² x plus 81 to the power, in place of cos²x we will put 1 minus sin² x, 1 minus sin² x equal to 30. Now we will write 81 sin² x plus here 81 raised to the power 1 into 81 raised to the power minus sin² x equal to 30. Now we can write 81 raised to the power sin² x plus this 81 will remain here and we will shift this in the denominator. 81 sin² x equal to 30. Here which formula we have used? A raised to power minus 1 equal to 1 upon a raised to power plus 1. This formula we have used here, exponential formula. Now let k equal to, we can put here 81 raised to the power sin² x. So we can put here k in place of 81 sin² x. So we can write here k plus 81 upon k equal to 30. Now we can take the LCM. Here LCM is k. So k plus 81 equal to 30. Now we will do here cross multiplication. Here in denominator is 1. So do the cross multiplication. This k will become k square. K square plus 81 equal to k into 30 becomes 30k. K square, this 30 shift this side, minus 30 becomes 30k plus 81 equal to 0. Now this is quadratic equation, so we can factorize this. So coefficient of k is 1 and 81 is, that is product is 81. Product is 81 and factors are 27 and 3. Minus 27 minus 3. So if we do the sum, so we get minus 30. Factors are minus 3 and minus 27. Product is plus 81. So we can write here k square minus 27k minus 3k plus 81 equal to 0. So we can write here, we can take common here from k, and here we will take common 3. So k into in bracket k minus 27, here minus 3 we will take common, so here remain k minus 27 equal to 0. Now here common is k minus 27, k minus 27 we will write in one bracket k minus 27, in another bracket we can write this k and this minus 3, k minus 3 equal to k minus 27 equal to 0, k minus 3 equal to 0. Now we will get k equal to shift 27 from that side, so minus 27 becomes plus 27, k equal to shift 3 that side becomes plus 3. Now recall 81 sin square x equal to k. Now put this value of k is 81 raised to the power sin square x equal to this 127 value. Here 81 sin square x equal to 3. Now 81 we can write 3 raised to power 4 raised to the power sin square x equal to here 3 raised to power 3. Here we write 3 raised to power 4 sin square x equal to 3 raised to power 1. Here we can write 3 raised to power 4 sin square x equal to 3 cube. Here 3 4 into sin square x equal to 3 raised to power 1. Now here base are same, so their powers are also equal. So we can write here 4 sin square x equal to 3. Here 4 sin square x, here power is 1. Okay, so can write here sin square x equal to 3. 4 is in multiplication, after changing side here it goes in division. Here sin square x equal to 1 upon 4. Now sin x, we can remove this square root sin square x, taking square root on both sides. Here also taking square root 4 by 3 by 4. Here taking square root sin square x is equal to under root 1 upon 4. Now here square and square root will remove, so remain only sin x is equal to under root 3 upon 2 plus minus. Here two values we get, so here square and square root will remove, so we get sin x equal to square root of 1 is 1 and square root of 4 is 2, so we get 1 by 2 plus minus 1 by 2. So we get here values of x. 4 values of x are sin x equal to under root 3 by 2 plus, and here minus under root 3 by 2, and here values of sin x equal to plus 1 by 2 and minus 1 by 2. So these are the 4 values of sin x. plus minus root 3 by 2 and plus minus 1 by 2. So in this way we have done this solution. So see once again this one. In this way we have find the value of x, sin x, and see for the sin x plus under root 3 and minus under root 3. See this graph, sin 60 degree is equal to root 3 by 2 plus root 3 by 2. Here sin 30 degree, this one sin 30 degree. This sin 120 degree is equal to root 3 by 2. Then here sin 240 degree is equal to plus root 3 by 2. And here 3 degree, sin 300 degree is equal to minus root 3 by 2. This is about the values of sin plus root 3 by 2 and minus root 3 by 2. Now for the another values of sin plus 1 by 2 and minus 1 by 2, this another graph is given here. Sin 30 degree is equal to 1 plus 1 by 2 and sin 330 degree is equal to minus 1 by 2. Here see sin 60 degree is equal to, and here this from this to up to this one 150 degree. So sin 150 degree is equal to plus 1 by 2 and sin 210 degree is equal to minus 1 by 2. So in this way we can find the values of x and x. Okay, if you are new on this channel, so you can subscribe the channel, like and share the channel. Thank you.